Good to have you back with us on the Querying with Transact-SQL course. We're up to Module 9, so we've covered a lot of ground so far on this course. And up till now, we've pretty much focused on querying tables and getting data out of them. That's pretty much exclusively been what we've looked at. In this module, we're going to turn it on its head a little bit and look at, well, what happens when we want to update or insert or delete data that's already in tables. So we have a number of things to look at. We'll look at inserting data into tables. And as part of that, we'll look at what we do with rows that might have identity columns, some unique identifier. How do we generate that? We'll look at updating data that's already in the table, so changing values of different columns. And we'll look at deleting data, removing rows from tables and getting rid of data that we no longer need. So quite a lot to cover. All right, inserting data into tables then. Obviously, I can just insert a row and I can specify the values that I want to insert into that. So I could explicitly say, insert a product with this product ID, this name, this price, this color, and whatever. I can specify those values. If the table that I'm inserting into has an identity column, so you want to just quickly remind us what an identity column is.
So a lot of our IDs we've seen have numbers, and they're unique. They have to be unique, because it's what's called a primary key. It uniquely identifies that row. One straightforward way of making sure that's unique is making sure that we have a counter. So the first one is number 1, next one number 2, 3, 4, 5, 6, 7. And automatically it would generate the next number. We can actually, in SQL Server, tell it not to go in 1, 2, 3, 4, 5. We can make it jump a few as well if you wanted to. So you could actually deliberately make it do every 10 if that's
so
more useful to you.
Increment by a different amount. Yeah.
Or we could even start a different number, because we already have 100 products and we're adding into that, and I would like to start at 101. We can start a different number if we wanted to.
But yeah, so I guess the point is when we create the table, we specify this column is an identity column. We tell it what they call the seed in the increment, where to start from, how much to count up in. And then every time I insert rows into that, I don't insert an explicit value into that column. It automatically generates a unique number using that sequence of numbers for that table. Yeah?
Yeah. I think just another point on that we need to remember, though, that in the future we may well delete one of those rows. They're not a counter. You can't go to the last one and say we've got 76 products because it's number 76.
Because we may have deleted 73 or whatever, yeah. So yes, so we got an identity is a fairly unique number that gets generated. We can insert into a table without inserting explicitly into that column. We just have the ID generated for us. And similarly, we might have columns that allow null. We've seen nulls quite a lot in this course. I might have a column that allows a null value. Perhaps it's a middle name column or something like that. And I can, explicitly insert a null, or I could just not insert into that column. And SQL Server knows that, well, this column allows null. You didn't provide a value for it. Therefore, it's a null. And the other thing that we can do is we can create default value constraints. So a classic example of this might be in an orders table. It's a sales orders table. There's an order date. And I might set up the table so that, well, by default, if you don't tell me the date, I'm going to assume it's today. I'm going to assume the order is right now. And it will insert the current dates and perhaps the current date and time into that column. So I could specify default values that are inserted if the insert doesn't specify what that value should be. I can use nulls, and I can insert nulls if that value isn't provided. And I could insert identity columns. And like I say, like it says on the slide, you can explicitly specify null, or if you don't provide the value for that column, then if the null is allowed, then the system will let the row in and just put a null in that location. So that's inserting values. If I'm inserting a row of data, I can do that. I can also insert into a table using not explicit values that I'm providing as part of my application code or whatever, but I could insert the results of a query against another table. So if I want to transfer rows or duplicate rows in one table across into another table, then I could insert the results of a select statement against that table. And to be technical, I can also insert the results of an execution of a stored procedure, which we'll talk about a little later on in this course, which also returns rows that get inserted. So it's not just about inserting one row at a time. I can insert multiple rows that are the results of a query as well. There is one final option, select into. What select into does is it creates a brand new table from the results of a select statement. So if we talked about insert from a select, the table I'm inserting into would already have to exist in that case. If I use select into, I'm explicitly creating a new table and populating it with the results of the query. Now the new table won't have any constraints or indexes or primary keys or any of that kind of stuff. It's just a new table with a bunch of columns that contain the results of the query. And I guess one point we do need to make about that is that currently, at the time that we're recording this, is supported in SQL Server, but it's not supported in Azure SQL Database, so you can't use select into.
But you could create a table and then do an insert select statement, so you can get the same results.
Yes, if you know what the schema of the result is going to be, you could create a table ready for your results and then use a select into. So it's not really a major blocking issue. So we talked a little bit about generating identifiers, and we talked about this notion of an identity column. So in an identity column, we generate sequential numbers automatically every time a row is inserted. And you can specify, like we said earlier, optionally the seed and the increment. So I could, by default, it will start at 1 and go up in ones. But I could start at 100 and go up in tens if I particularly wanted to have a sequence of IDs like that. One of the obvious questions is, if I just inserted a row into a table, now this might be inserting an order, and the order ID might be an identity column. How do I then get what the order ID was back again? So if you think about an application on a website where you place your order, typically the first thing it then says is, thank you for your order. Your order number is, and it tells me.
So would you just go for the highest order number?
Well, yeah, there is a bit of a problem there because, of course, multiple orders could be getting placed at the same time. So there's a risk that between your order being placed and you going to find what was the highest one in the table, someone else might have placed an order.
Your order.
Yeah.
Right.
So there are all sorts of issues with that. To help you with that, there are a bunch of built-in global variables and functions that you can use. And we'll talk about each of those here. There's a global system variable called identity, which gets the last identity value that was generated in the current session. So for this connection, what was the last identity value I generated? Now that might be useful if I'm inserting in an order and getting back the order ID. You kind of have to be careful though, because if you insert an order and that order includes order details, which you then subsequently insert, and those have identity columns as well, then actually the last identity that you inserted will be the last of the order details. It won't be the order number.
It's the last identity on any tables.
Yeah, it's the last identity that was created in this connection. There's another similar. There's a function that returns something similar, although it's not scoped to the entire session. It's scoped to the current scope of the query, the current query that you've used. And that will bring you back, the scope identity is the name of the function. It will bring you back the last identity that's in scope of the query that I've just executed. Again, it might not necessarily be the one you're looking for if you had a statement that inserted into multiple tables and each of those had an identity. But that's possible as well. The other, and I guess the most explicit way of doing this is the ident current function, to which you pass a table name, and it will pass you the last identity inserted into that table. Now, that might sound like that's exactly what we need, but again, that's across all sessions. So if someone else is inserted in that table, it will get the identity they generated. So it's not an exact science. Typically in that type of scenario where I'm inserting an order with an order ID and I want to get that back, well, first of all, I try and avoid having identity columns on my order details. And secondly, I usually use scope identity to get back the value.
So you could grab that value before you go on to do other things that would then also use identity.
Yeah, and particularly if it's within a transaction, because you're going to get the value that's within your transaction before that transaction rolled back. And we will talk about transactions later on in the course if you don't already know what they are. So you can see the code example. I'm inserting into the sales orders table a customer ID and an amount, and I'm explicitly specifying the values that are being inserted. So it's customer ID 12, the amount is 2,056.99. And then once the insert is done, I'm selecting the scope identity, and that's the order ID. That's the last identity that was inserted. Now, there is actually another way of dealing with identifiers, and I guess we first of all need to set up why we need another way to do this. If you think about perhaps a database where you have two types of order, perhaps you have orders that are placed through your website, and you have orders that are placed by customers that you explicitly ship to. So you've got retailers that buy things from you, and you've got web customers that buy directly from you. Now, you might choose to store those order details in two separate tables, because you might want details from the retailers about the supplier contact ID and the telephone number and the address of the store and all that kind of thing. And for your web customers, you might have a different set of columns that you want to store about those. So you've got different tables for your types of customers, and you might have different details for the orders themselves. So your retailer orders might include some sort of purchase order number, whereas your web orders generally won't have that because you won't have raised a purchase order. So in that case, I'm inserting into two different tables, but I quite possibly want to keep my order numbers unique across both tables. And an identity column won't do that. An identity column is specific to this table. If I create an identity column on another table, then it will generate its own numbers independently. Now, you could be clever and you could generate a seed and an increment on one table that makes sure everyone is an odd number and everyone on the other one is an even number, but really that's not the best solution. So an alternative is to use something called sequences. And a sequence is an object that you create in a database that generates sequential numbers, but it's not tied explicitly to any one particular table. It will generate, every time you need a new number, you just ask it for the next value, and it literally is select next value for the sequence, and that will give you that number, and you can then use that in any table you like as an identifier. So that would get around this problem of wanting to have a unique order number across two different order tables, or 3 or 4, however many order tables you've got. You just have this central sequence that controls, issuing new numbers.
So we could then union those web queries with those retailer queries, and it appears just as
these
it should.
These are all of our orders, and they've all got a unique number.
Unique numbers.
Exactly. So let's dive into a demo of inserting data into a table. And to start off with, I'm going to create a table. The scenario here is that in our AdventureWorks organization, we want to keep a log of telephone calls that are made. Every time that we call a customer, we want to keep a log of when that call was and what was discussed and so on. So to do that, I'm going to create a table called call log in the sales LT schema. And I'm going to give each call an ID, which is an identity column. So it's going to generate. I haven't specified a seed or an increment, so it's going to start at 1 and then 2, then 3, and so on. I'm going to specify the call time, and by that I mean the date and time that the call was placed. I'm going to specify the salesperson that placed the call, because we're talking about salespeople calling customers here. We'll specify the customer, and notice this one references the customer table. This is what we call a foreign key, so that's referencing an existing customer in the customers table. We're going to specify the phone number that we actually called, and some notes about what was discussed on the call. So there's various different columns in the table that we're defining. The other thing to note here is that the date time column for call time has a default value based on the getDate function. So if I don't specify the date and time, it's going to default to the current date and time.
But you could override that by giving it a value. If you knew the sale was placed yesterday, you could...
Exactly. If a call was placed yesterday, I can explicitly say, well, yeah, this one was placed yesterday. If I don't do that, it'll assume it was placed today. The other thing to note is that a lot of these columns don't allow nulls, so definitely don't want nulls in my primary key. I don't want a null in my call time or the salesperson or the customer ID or the phone number, but I will allow null in my notes column. So if there weren't any particular notes, perhaps I called them and they weren't in and I just left the message. There's not really any point in making notes about that. So we maybe don't necessarily need notes. So we'll allow null in the notes column. So let's create the table. And that's now ready for me to use. And the first thing I'm going to do is I'm just going to insert one single row into that table, and I'm going to explicitly specify values for all of the columns other than the call ID, which is an identity. It gets generated automatically. So the syntax is insert into. The into is actually optional. You could just say insert in the name of the table. So schema and table. And then values, because I'm explicitly inserting some values into that table. And in a parenthesis list, I've got the value for the first column that isn't an identity, which in this case is the call time. So that's the specific date and time. The value for the salesperson, the value for the customer number, and this is customer number 1, the telephone number that I dialed, and I'm inserting some notes about that call, about what the call was about. So fairly straightforward, insert into that table those values. Let's go ahead and do that. And I get back a message, one row affected. And that can be quite important when you're building applications. The ability to figure out how many rows were affected by an insert and so on can be useful, especially if you're checking to see were no rows affected, did something go wrong and nothing was inserted or whatever. And if I actually query that table now, we can see that that's been inserted into there, and I can see my identity numbers working here. It's generated number 1, and I've got all the values that I inserted into the table. So far, so good. What if I want to use nulls and defaults? So I don't particularly have any notes that I want to keep a record of, so I'm going to insert a null into that column. And I don't want to say this call was made yesterday, it was made right now, I just want to use the default value for that. Well, I can do that by specifically saying, insert the default value into this column, and insert a null into that column. So it's very much like inserting values, except I'm explicitly saying, insert the default value into the date and time column, and insert this null value into the notes column.
But you know the order you're putting those things in.
Yes, so I know what order the columns are defined in, so it's really just the ordinal position in the list that's determining which column the data gets placed into. So if I go ahead and do that, we can actually see that it's inserted the default value, which was today's date, so you can tell when we recorded this, and you can see that it's inserted explicitly a null into the notes column. But you raise a good point. Up till now, I've assumed that the ordinal position of the columns is, what's in my values clause. Or what if I don't know what order the columns are defined in? Or what if the table's been modified and a new column's been added that allows nulls or has a default value, but I don't know where in the sequence of the table that column is? Well, what I can do is I can explicitly say in the insert part of the statement which columns I want to insert values into. So I'm inserting, in this case, just into the salesperson, customer ID, and phone number columns. And I've then provided the salesperson, customer ID, and phone number values. I haven't mentioned the call ID because that's an identity. I haven't mentioned the call time because that has a default value and that's what will be used. And I haven't mentioned notes because I'm not inserting any notes and it allows nulls, so it will just place a null there.
So if something didn't allow nulls and didn't have a default or an identity,
I would get an error.
Have to supply it.
Yeah, I would get an error. You have to supply it. If it doesn't allow nulls, doesn't have a default, and isn't an identity, you're going to have to supply the value. But if I go ahead and insert that there, one row affected, so it's been successful. And if I query the table, I can see that again, even though I didn't explicitly say default, because I didn't provide a value for the call time, it's used the default. And although I didn't explicitly say null for the notes, because I didn't provide any information about the notes column, it's inserted a null. So far we've inserted one row at a time. I can actually use this values clause to insert multiple rows if I want to do that in a single insert statement. Rather than repeatedly running lots of insert statements to insert lots of rows, I can do one insert statement that inserts lots of rows. So in this case, I've got an insert statement here that for the first row adds an explicit date, and you'll notice I'm using a function. It doesn't have to be a hard-coded value, a literal value. I'm using a function to get 2 days ago as the value here. This is actually date add in, I beg your pardon, 2 minutes ago. Date add in minutes minus 2 to the current date and time.
But that's actually dropping in the date, or is it dropping in the function? Would it update itself afterwards?
It will drop in the result of the function. It's the value. It won't then continue update to always keep itself 2 minutes ago from now.
Okay.
It's whatever the result is gets inserted. Then I've got the salesperson, the customer, the telephone number, and there are no notes for this one, so I'm inserting null. And then for the second row, I'm inserting the default value for our the call time, this salesperson, this customer, this telephone number, and some notes in this one. So if I'm inserting multiple rows, they don't all have to include all the same information. If I'd had a list of columns after the insert, they would all have to have those columns. And because I haven't, they've got to have something for all of the columns other than the identity. But that could be a null or it could be a default. So I'll go ahead and insert that. And I get 2 rows affected returned back. And if I have a look at what's in the table now, sure enough, 2 new rows are in there, and I can see that one was 2 minutes previously, and then I've got the one that was just inserted at this current time. So far, I've been explicitly providing values, and actually that's fairly typical. If you're building an application, typically the application gathers the data from the user and then does an insert to insert it into the table. What I'm doing now is I'm going to look at inserting the results of a query. Perhaps I already have another table that's got some data in it, and I want to take that and insert it into this table. So in this case, I'm taking data from the sales customer table, and what I'm doing is I'm saying that I did a sales promotion call, and I'm going to go ahead and do that just now, and I'm going to do that for all of my contacts at the Big Time Bike Store. So I'm about to do a sales promotional call to there. I've already got in that table, I've got the relevant salesperson, the customer ID, the phone number, and I'm going to add a note that says this is a sales promotion call to there. So I don't need to explicitly provide those values. I can go and get them from that other table. So insert into that table, select this from the other table. And it finds 2, so that I've obviously got 2 records for the Big Time Bike Store customer. There must be 2 different contacts there. And if I go and have a look at that, sure enough, I've got 2 different sales promotion calls to that customer, both made by the same salesperson, but to different customers in the customer table, presumably because there's 2 contacts, perhaps that's 2 branches, 2 locations.
So you've actually supplied some information with that note,
the notes, yeah,
and grabbed some information from existing data.
Yeah, so I've combined the explicit values and data from a table. Now, we talked about identities, and we've been inserting identities. You can see the call ID is being, incrementally added each time I insert a row into here. Again, like we spoke about when we had the slides, we talked about how do I get that value back, and we saw a number of functions. In this case, I'm going to use the scope identity function. So what I can do is do my insert, and then get back the ID of what I inserted. So let's go ahead and do that, and I'm just going to do these one by one. I could, typically an application would sort of submit these as a batch and run them all in one go. Because I know I haven't got any other users at the moment, I'm not going to worry about losing the identity. So I'm going to go ahead and do the insert. And then if I have a look at scope identity, I can see that actually the value 8 was used. That's the last identity within the current scope. And if I go and have a look at the data in the table, sure enough, I can actually see that row number 8 is the one that I just inserted there. Now, there might be occasions where I want to explicitly override that identity. Perhaps I have gone and deleted a call that I made previously, and I then want to reinsert the details of that call, but I want it to still have the original number. So I want to override, I don't want to generate a new identity, I want to explicitly provide the identity. And there is a way of doing that. I can set an option called identity insert on for a particular table. So if the table has an identity column, I can do this set identity insert for that table on. So I'll go ahead and do that. Then I can insert into the table and explicitly specify, I'm inserting a call ID value here, and it's number 9 in this case. So I'm going to go ahead and insert that. And what you probably immediately then want to do is turn identity insert off so that any subsequent inserts get the automatic identity. And now if I go and have a look at that table, sure enough, it's explicitly inserted number 9.
That's a 9 because you told it to be a 9.
Because I told it to be a 9.
Yeah.
And it will now go on, the next time I do an insert, it will just carry on using the identity columns. The next one will be 10 and so on automatically. And after inserting data into a table, we might want to talk about updating data in a table. So I've got a table that's got some data in it because we've inserted it. And what I might want to do is update it. And to do that, we have the update statement. And what that will do is it will update all the rows in a table or view, which might be what you want. I might want to do a price increase across the board and update every single product in my products table. More likely, I'm going to want to filter. I'm going to want to use a where clause to say only update the rows where this criteria is true. So a bit like a select statement that restricts the rows that you select out, you can use a where clause and an update statement to restrict the rows that get updated. And the other thing that we can do is we've got the set clause in the update statement where I set different columns to specific values. And in the example here, you can see that I'm updating the unit price. I'm referencing itself. I'm updating
So you can
the unit
actually
price.
set it to itself, multiplied by or added to or something. So it depends on what it is at the moment and what it will be.
Exactly, yeah. So in this case, I'm saying for category ID 1, where the products are not discontinued, I want to increase the price. But I can't just explicitly say, here's the price I want you to set, because of course all the products might be different prices. So I've referenced the existing price and then just used a function to, or rather use an expression to indicate what I want to update it to. So you can update to a literal value, or you can update to an expression, and that expression could reference the existing value. So you can see that I'm setting, in this case, I'm setting the unit price. You can set multiple columns to different values. So it's not, you don't have to do an update statement for each column that you want to change. If I wanted to change the price and also the, I don't know, the notes about that column or something, I could set unit price equals whatever, comma, and then notes equals whatever. I could update multiple columns. Now we're providing the values in the set clause here. The other thing you can do, much like you can do an insert into a table from another table, you can do an update from another table. So I could update a table based on values that I get from a query. So update the columns in the where clause, update the rows that are defined by the where clause, setting the columns to whatever the columns are that are returned by this query in the from clause. There's pretty good documentation, some great examples of using that type of technique and various different approaches to updating data in the documentation. And I do recommend go and have a look at the Transact-SQL documentation in MSDN for that. So only the columns specified in the set clause are modified. I can specify multiple columns in the set clause, but only the ones that I specify are affected. The other columns remain at their existing value. So if you have an identity column, for example, it doesn't generate a new ID or anything like that. That stays as it was. Only the columns in the set clause are affected.
So what you've done at the moment is we've looked at inserting and we've looked at updating. So what if we were to add a new product, and we've got some products coming in now we've got a 5% increase across the board, but then also, as well as some new prices for products, we've got some of them are new products. So if I'm putting in something that's brand new, we don't have it yet, I want to do an insert. But if I'm putting a new price in for something that already exists, I just want to update the value. I don't want a new record, I just want to update the value of the existing record. And how can we deal with that situation?
Right, and that's a really common situation, especially in things like data warehousing scenarios where you want to do, some people call it an upsert. I hate these kind of word crashes that people use, but some people call it an upsert. Basically what we're going to do is update records that are already there or insert new records if there aren't already records there. And to support that in Transact-SQL, we have the merge statement. So what merge does is it modifies data based on a condition. And what we do is we look at when the source matches the target. So typically you've got data in perhaps a staging table where you're loading data in, and so you've got a query that gets data out of the staging table, and you've got the table where you're either inserting or updating, so you're loading data into that table. And what you're going to do is you're going to compare the source to the target, and you're going to say, if there's a match, so the record exists in both the source and the target, so perhaps a product with this product ID already exists, then I'm going to do an update. I'm going to update the price of that product. But if the source doesn't match the target, so it's in the source but not in the target, well, clearly this is a new product. So I'm going to do an insert a new product. And there is, of course, actually a third variant. I might have a product that's in the target, so it's in my existing products table, but it's not listed in my new list of prices that I'm loading.
So we don't have a new price for it, so we're not going to stock that product anymore.
It may mean that, and you would write the logic to do whatever you want. It may mean, hey, there's just no change to this product, or it may mean, if that product's not in the new list, then we need to get rid of it. We're no longer going to sell it. So I might set it to be discontinued, or I might delete it. Mm-hmm. So we've got this option of looking at the source and target, comparing them. If it matches, what do we want to do? If it doesn't match because it's in the source but it's not in the target, what do we want to do? And if it doesn't match because it's in the target but not in the source, what do we want to do? So the syntax is there's an example here. You can see the syntax. It's merge into rather than insert into. production products as P, using the source that I want to compare it to. So the using clause is where I define the source. In this case, the source is a staging table, and that could be any table expression. So it's just, in this case, it's a table. And I'm matching it based on the product ID in this case. So this is a bit like a join clause in some ways. It's the way that I'm saying I want to relate these two tables. How do I determine if they match or not? When they're matched, so in other words, when the product ID in the source is equal to a product ID in the target, then I want to update. And notice I don't have to say which table I'm updating because that's implied by the merge. So I just want to update, and I want to set the unit price in the target equal to whatever the unit price is in the source, and set discontinued equal to whatever discontinued is in the source. So I'm taking the values in the source and updating the target to use those values. When not matched, and I haven't in this instance bothered to check which way it doesn't match, I'm just saying if it doesn't match, then I'm going to insert whatever there is in the source that isn't in the target, and it's going to include all of the values that I want to insert. And as I say, that could be more sophisticated because I could check which direction it doesn't match in and do something different accordingly.
So you could actually you don't have to have an update and an insert. You could have an update and another update that does something different, or an update and a delete.
Yeah, and exactly. And the classic example of that would be you typically wouldn't delete a row because the product was discontinued, but you would set its discontinued flag. Mm-hmm. Yeah. So we talked about inserting and updating, and we briefly mentioned deleting data. I guess it's sensible to talk about, well, how do we delete rows from a table? The answer, unsurprisingly, is we use the delete statement. And something to watch out for here is a really common issue. I'm sure you'll agree, Jeff. If you don't specify a where clause when you say delete from a table, what do you think it does?
Deletes everything.
It deletes every row in the table.
Hopefully not too common, but drastic if done at all.
Exactly, yeah. And it's more than once I've accidentally issued a delete statement and realized I've deleted all the rows in the table. So it's kind of fairly major consequences. So usually a delete statement has a where clause that specifies which of the columns I want to delete. So in this case, which of the rows I want to delete rather. So in this case, I'm specifying delete from the order details table where the order ID is 10248. So I'm very explicit about that order was maybe inserted in error or something like that. So go ahead and delete that out of the table. Now, the alternative to deleting all of the rows using delete, I said if you use delete without a where clause, it deletes all the rows. Well, SQL Server records transactions like that as they happen. So there's a little bit of overhead if I use a delete statement to do that. And I can eliminate that overhead by using this alternative approach called truncate table, which effectively deallocates the physical rows. It goes ahead and eliminates the data in the table, but in a very efficient, very quick manner. So if you do actually want to go ahead and wipe the contents of a table, truncate table is generally a more efficient way to do it.
So we don't have a where, it's essentially doing that delete statement without a where.
Yeah.
Very, very quickly. Yes,
it will go ahead and truncate the entire table. There's no way to restrict which rows get deleted. Truncate table deletes all the data in the table.
And the table itself, we've still got the structure, we've got the columns there, empty.
Yeah, table remains. The table definition itself remains, but all the data is wiped out of it. It's typically used in scenarios where perhaps you're creating you've got staging tables that you load data from some external source into, and then when you're ready to load them into their actual target tables, you might use the merge statement that we talked earlier on. So you might load new data into a staging table, then use a merge statement to insert or update your actual production table using that, and then when you finish doing that, you want to empty the staging table, but you want to keep it around for the next load. So you truncate the staging table.
Because otherwise the next time it's going to try and stage the same data again.
Yes, exactly, yeah.
Right.
So there are cases where it's used. It's not in a typical online transaction processing application database. It's not something you do a lot, but there are scenarios where you want to truncate the table to get rid of all the rows. Now there's a mention there that truncate table will fail if the table is referenced by a foreign key constraint in another table. And the same is actually true with delete. So we haven't really sort of talked much about defining tables and keys and constraints. But we did mention earlier on when we created a table, there was a foreign key. There was a relationship between my call log table and my customers table. The customer key is actually in the call log table.
So it must be a real customer that you're call logging for.
So that foreign key constraint is used to make sure whatever key value I put in this table there must be a record for it in the table that I'm referencing. If you have foreign key constraints in other tables that reference the table you're deleting from, and you try and delete that row, either using delete or truncate, you will get an error. So a good example of that might be you've got, well, let's look at our call log. We've got a call log table that references our customers table. If I tried to delete a customer for whom I had a call, that would fail because I've got details about that customer in another table.
But we could delete the call.
We could delete the call.
That's just one individual call for that customer.
Right. Yeah, exactly. So it's the foreign key side you can delete. The primary key side you can't delete if there are foreign keys still referencing it.
So you don't get left with these sort of orphan records that are not attached to anything.
Exactly. And there are one or two techniques we can use to deal with that situation. Should I definitely need to delete a customer and all of their calls, I can do that. There are ways that we can do that. We don't really cover them on this course. So there are ways around that, but just be aware if you're using a delete statement and the row you're deleting is referenced from another table, then you won't be able to delete it. You'll get an error. So let's take a look at all these different types of modification we've talked about here, and let's start with doing an update. So I've got my sales log table, you might remember, and it had some data in it. So I've got my various calls that I've logged, and quite a lot of them, because I'm allowing nulls in the notes column, quite a lot of them have a null value in there. And generally, although I'm allowing nulls, it's not really something that I'm comfortable with having null, because it kind of means unknown. I'd like to be more explicit than that. So I'm going to update this table so that where currently the notes is null, I want to change it to explicitly no notes. I want to actually put a string value in there. So if I go ahead and do that update, there were 5 rows affected. And then again, this is where that row count that comes back is really useful. With an insert, you generally know how many rows you're inserting unless you're inserting from a query. With an update, you might want to know how many rows were updated, so that's pretty useful. And if I go and select from that table, I can now see that where previously I had nulls, I've now got no notes in that column, so it's updated that column. And as I said when we looked at the slides, you don't have to just update one column. I could update multiple columns, so I could set the salesperson equals an empty string and the phone number equals an empty string in this case. Now, if I do that, what do you spot immediately about that query, Jeff?
So yeah, we can see in there that you're updating the call log and setting the salesperson to nothing and the phone number to nothing, but you're doing it for everyone. So that's fine if we wanted to clear out, we don't want phone numbers or salespeople anymore, but we're not going to have those for anyone.
Right, yeah, there's no where clause, so it's going to affect every record. Right, and just to prove the point, because I am that crazy, we'll run it. There were 9 rows affected, and if I now go and have a look at my call log table, I can actually see that my salesperson column and my phone number column now they don't have null in it, they have an empty string, right? So, well, that's not really very good. What I might want to do is fix that, and I'm going to do that by updating from a query. So I'm updating the call log table, I'm setting the salesperson equal whatever salesperson value I get, phone number equal whatever phone number I get from the customer table, where its ID matches the customer ID in my call log table.
That's handy, you've still got the data you just deleted.
Isn't it handy that I've still got that? Yeah. So I could go ahead and do an update. And the point is it's an update from. So I'm not explicitly setting the values. In the same way I could do an insert from a query, I can do an update from a query. That's affected 9 rows. And I can breathe a huge sigh of relief because I've now got my salesperson and my phone numbers back again. So updating data is pretty straightforward using the update statement like that. What about deleting data? Well, I might want to say I want to delete all the older calls. I might want to archive off some of these calls and say I'm not really interested in calls that took place a while ago. In this case, I'm only interested in the calls that happened this week. So I want to get rid of any calls that happened before 7 days ago. And you can see the very first one I inserted actually was on the 1st of January, which given that today, according to this, is the 27th of January. So that's an old call. I don't really care about it anymore. Let's go ahead and delete that. 1 row affected. And if I have a look and see what's in the table now, sure enough, call number 1 is now gone. So that's no longer kept.
So our identity now as well doesn't actually, it's not a row count anymore.
Yeah, exactly. Yeah, the last identity is 9, but there aren't 9 rows in the table. There's only 8 rows in the table. Yeah. And then what I might want to do is eventually say, well, actually, let's wipe that call log and start again. Let's get rid of all the records in there. So I can go ahead and I could truncate the table. I don't get a row count. It just goes off and deallocates the table. And if I then do a select, it's an empty table now. It's been emptied, ready perhaps to load some more data into. So this module was a bit of a departure from the previous ones. We'd previously talked about selecting from tables and really just focusing on getting data out of tables. In this module, we've talked about inserting new rows into tables and either individual rows or rows that are results of queries into a table. We've talked about updating existing rows in tables, either by updating specific values in the columns or by using that merge statement that we talked about, where you might want to check and see if the row already exists, then update it. If it doesn't, then insert it. And then finally, we talked about deleting data from tables, and we talked about using the where clause to restrict which rows get deleted, and we talked about using truncate table if what you want to do is just completely empty the table. So some useful things there that you will use if you're using Transact-SQL at all to work with databases. A lot of the time it is querying to get reports, but almost certainly you will be updating and inserting data at some point. So some useful stuff there. There's a lab for you to go and try. And as always on this course, we'll get you to use the AdventureWorks LT database in Azure SQL Database to go and try out some of the lab exercises. So download those labs and make sure that you have a go at that. And when you're comfortable that you're inserting, updating, and deleting data in tables quite happily, come back and join us for the next module when we'll look at some techniques for programming with Transact-SQL and doing some more sophisticated logic in your Transact-SQL code.